All right, this is 1.9, solving equations algebraically and graphically. All right, so first of all, solving it algebraically, we've gone over how to solve quadratic equations using completing the square, quadratic formula, factoring, the square root method. We've gone over how to do that, so that's not necessarily going to be covered in this video. But I want to emphasize how to do this graphically. And on a graphing calculator, it would be very easy to do as well. We would just have to type it in, push graph, and then find the zeros. Because remember, when we're trying to solve for x, that's what we're trying to find. When we get x equals whatever this is, let's say it equals 7 and negative 3 or something like that. What those are zeros. Okay, that's what we're trying to find, is where those zeros hit. And that's when we're trying to solve the quadratic, we're trying to find those zeros. That's what we want to try to find when we're trying to solve x. And on a graphing calculator, it'd be very simple. Again, just push graph and then find those x-intercepts to be able to do that. But even to the nearest tenths or hundredths or thousandths, you can easily do that on a graphing calculator. But how do you do it without a graphing calculator? Well, let's first of all, we know this is a parabola, and we know it's a positive a. There's a positive number, so we know the parabola is going up. Okay, so just remind ourselves of a couple things. The other thing, what we can always find is if we start an XY chart, we can easily start finding the y-intercept by plugging in 0. If we plug in 0, we're going to get 2. So we know 0, 2 is a point on that parabola. And that's easy to find. The other thing that you should consider is trying to find the axis of symmetry. Remember, the parabola always has an axis of symmetry. It goes right through the middle. And to find the axis of symmetry, it's x equals negative b over 2a. So on this problem, that's going to be positive 4 over 2, which is at 2. So there is an axis of symmetry, the middle of the parabola, at x equals 2. And one of the cool things, since I know it's going up, and since I know that a parabola is symmetrical, I know another point on there is right here. So remember, it's symmetrical. So 2 spaces to the left, 2 spaces to the right, it's symmetrical. So it goes there. So it's 2 points right there. And I know that x equals 2 is the middle of the parabola. So it literally is one of the other points on there. So if I substitute 2 into x, I'm going to get 4 minus 8 plus 2, and I'm going to end up getting negative 2. That right there is the vertex. So I could actually start graphing the parabola right now. So I know what the parabola looks like, and I did it within about a minute's time. I could have done it in about a minute's time or less to be able to do that. But remember, what am I trying to find? I'm trying to solve the equation. So graphing the parabola right now doesn't actually answer the question. So what am I trying to find? I need to find out what x equals, like where does it actually cross the x-axis? And so I want to basically find this point right here and this point. And again, I just use graph paper. My graph may not be all that accurate, but it's approximately correct. So I know my 0 is somewhere in between 0 and 1. That's one of my zeros. And then the other one is approximately 3 point something. So how do we actually find it? And let's just do it to the nearest tenths place to make it easy. So what you could do is, again, without using the quadratic formula, okay? If we just use the quadratic formula, we can find the exact answer, okay? But how do I do it pure graphically? Pure graphically. Well, what you could do is you could literally just plug in a point, just a random decimal point. Let's plug in just halfway in between. Maybe that's at 0.5. So if I substituted in 0.5 into x, so if I substituted this in, and what I'm trying to find is a point, so 0.5. If I substituted that in, I'm going to end up with 0.25. Now, so at a half, so you'd have to get very accurate, like really blow up your graph here, but at 0.5, it's slightly, see, I can't even, it's hard to do it on this graph, but basically what you're doing is here's 1. At a half, it's slightly above the line. So it's literally like right there, right above the line. And I'm trying to find out where it will equal 0. And so now, since that's above the line, I want to try to find something that's below the line, so I'm going to plug in 0.6. And then I'm going to see which one is closer. So 0.6, if you substitute 0.6 back into the equation, you're going to end up getting negative 0.04. So at 0.6, so again, we're talking about really, really close. So at 0.6, so let's say this is 0.6 is right here. So 0.6 is slightly below the x line, and we're trying to find out where it will hit, or at least, since we're just doing a decimal approximation, we want to find out the closest one. Well, this one right here is below the x line. Remember, what we're trying to find is when it will hit 0. What we want to find is the exact decimal. That would be nice to find the exact decimal that will equal 0. Well, we're just approximating, and so this is slightly below the x equals 0, and this one's slightly above, but notice this one right here is closer. So 0.6 is my answer to the nearest tenths place. So x equals 0.6. I really should put approximate. X equals approximate 0.6. Again, to the nearest tenths place. If I wanted to go to the hundredths place, then I would have to get a little bit more accurate. I would have to go, is between 0.5 and 0.6, there's 0.51, 0.52, 0.53, 0.54, 0.55, and so on. And I would have to use those decimals. I would have to literally try 0.55, 0.56, and plug them into this equation and see which one is closest to 0. And then that would be to the nearest hundredths place. And it's just a bunch of calculations you would have to do. But again, you can do it without a graphing calculator. All right. So again, to solve, and what I found right now is I found 1 0, again, to the nearest tenths place. So this is approximately 0.6. So again, approximately. So 0.60 is an approximate 0. And that's where it hits right here. Again, to the nearest tenths place. And I could do the same thing with this one. So this is, it looks like 3 point something, 3.2, 3.3, and you do the exact same thing. Just pick some random decimal, 3.2, and then plug it into this equation and try to go to find one that's above the 0 line, positive, and then try to find one that's below it, and then see which one is the closest. And again, if you did the quadratic, so let me just back it up a little bit. If I did the quadratic, I would end up with these two solutions. I would end up with x equals 2 plus the square root of 2, and x equals 2 minus the square root of 2. If I did the quadratic. And those calculations to the nearest decimal, 2 plus the square root of 2 is approximately equal to 3.4. So again, notice that's the decimal 3.4. So my guess, 3.2, 3.3 was close. So I would have had to keep going to 3.4 to find that. And then when you substitute in 2 minus the square root of 2, you're going to get 0.58, which again is 0.6. That's what we came up with. So using the quadratic obviously gives us a more precise answer. That is the exact answer where it hits. To be able to do that. But you don't have to use the quadratic formula. You don't have to use the graphing calculator. Now, let me show you on the graphing calculator. So if we had a graphing calculator, we have x squared minus 4x plus 2. If we were able to use a graphing calculator, you can push graph, and you want to find out exactly where it crosses, not approximate. So we're going to do second trace, and we're trying to find zeros. That's what they're called, zeros. And then you literally just move your move your cursor. It's going to ask you three questions. If you notice the question right here, it says left bound, right bound, guess is what it's going to say. So you literally move the cursor to where you think the 0 is, go to the left of that, press enter, go to the right of the 0, press enter, and then go back. It says guess, but you go back to where you think the 0 is, and you press enter, and notice 0.58 is your answer. So I highly suggest you don't just move the cursors. A lot of students just move the cursor and just, oh, it's 0.6. But if I ask you to do it to the nearest tenths place, that might work. But the nearest hundredths, especially nearest thousandths place, that would not work. You literally need to do the second trace 0 button and then do left bound, right bound, yes, for finding your two zeros. That's how you find your zeros on 1.9, solving equations using algebraic method and the graphing method.